Welcome to Spring LIB.
Okay, so we've got water molecules that are all carefully aligned, right? And they're all orderly, following the same basic pattern. That is what solids look like, right? Solids form orderly arrangements of atoms, right? It's like a ball stacked next to a ball, stacked next to a ball, and maybe some balls in between those balls, right? This is what solids look like, a regular repeating pattern of molecules. Okay, so that first picture is a picture of solid water, right? Now, liquids have a bit more disorder, right? Some of these may be rotated. They may condense down and fill in some of the gaps, right? So it's not going to be this regular repeating pattern. It'll be sort of randomly, not totally randomly oriented molecules, but they won't be quite as orderly and regular as in a solid. There's some degree of randomness to it. And that represents the fact that, water, I'm giving it away. This is a liquid. This is what liquids look like. The molecules are all close, but they're not completely regularly oriented or ordered, right? And this is why you can put your hand through water. The molecules can move out of the way, right? But if you want to put your hand through a solid, these are all tightly packed in here. They're rigidly in the orientation that they need to be in to lower the energy. Water is a lot more malleable, right? So when you see these random but still close molecules, that's liquid. The final example is gas. And gas, how I know this is gas, is that it is expanded to completely occupy the container that it's in, right? And there's no sort of, or not much, interaction between the individual molecules. They're all just sort of randomly in here. They're not preferentially clustered together, right? At this point, you can think of all the molecules as being totally independent of the other molecules. They aren't really interacting, and this is what gases are, right? It's free molecules floating in space.